Welcome to the ArcGIS Runtime SDKs for building cross-platform apps. My name is Rex Hansen, I'm a product manager for the ArcGIS Runtime. I'll be emceeing this venture today. I'm joined by Eric Bader, product manager with ArcGIS Runtime as well, specialty in Java, Qt, and a variety of other technologies. And Michael Timms, lead developer for Qt, QML, and Morten Nielsen, lead developer for our .NET SDK. Great, so let's go ahead and dive in. We'll get started. This is a 75-minute session packed full of good information. So just a quick agenda, cross-platform review. Just talk about where we are with cross-platform just to get us all on the same page and what we're going to be talking about here. And then just let's take a look at the ArcGIS Runtime cross-platform options. What are available today? What do we focus on as far as the ArcGIS Runtime team is concerned with respect to building cross-platform solutions? So first thing, just to get out of the way right at the beginning, is native versus web. Right, these are some statements here about native strategies, being able to leverage native strategies or native application platform strategies to be able to get the most out of your devices, be able to utilize those devices in a way that they were meant to be used, whether connected or disconnected, whether online or in the field. Right, so these offline workflows are critical for using native applications, right, and leveraging the device capabilities, GPUs, sensors, effectively within native applications. So the ArcGIS Runtime SDKs are geared towards building native apps. Right, and that's what we'll be talking about today. There's a complementary, or some would call it competing strategy, of using web APIs, web technologies, HTML, JavaScript, style sheets, CSS, to deliver solutions on devices, a variety of different device platforms. You can build with web technology, obviously you can build your application once, you can run it on multiple devices in a variety of different capacities, whether it's a container in a native app or it's a browser. There's a variety of different ways to be able to utilize your cross-platform web technologies. Generally, at this point, you're looking at whether or not you need to maintain connectivity, whether or not you need to be online. And right now, with respect to developer technologies at Esri, native SDKs are designed for both online and offline use. Web technologies are designed for connected or online use at this stage. Right? So that's one critical difference between the two. As far as reaching a wider audience, it really depends on the technology that you choose. Right? So a lot of folks have determined that using a web technology allows you to reach a wider audience because you can work with browsers or other controls that allow you to integrate that type of web technology into a variety of platforms. With native SDKs, it's reaching that point. There are a variety of different platforms and technologies, depending upon the platforms you choose, within which you can achieve near a very wide audience. You can reach a very wide audience using a native SDK, using a native development platform. So a couple things to keep in mind. We're going to be talking about native strategies, native capabilities with respect to the ArcGIS Runtime in this session. Great, so for building a native application, what are some of the considerations we need to think about here? Benefits, drawbacks, challenges, actually maybe said another way. Benefits, share application code. The idea is you have knowledge in a specific area, specific technology, and its tools and techniques. You want to be able to leverage that knowledge and use that across multiple platforms that you or your customers need. Right? So being able to share that application code to the greatest extent is key. Right? And be able to take advantage of the rich development tooling that's available for those platforms is critical. Oftentimes, this requires good design patterns, right? Being able to manage or manipulate or separate that logic out so that you can account for maybe some platform differences within those different technologies. But ultimately, the benefit is you're reaching more users, you're reaching more devices, right? And that's the key. You may need to, as part of the challenges, you may actually need to alter the user experience within your app to accommodate for different immersive feels, looks and feels within your application, and handling those idiosyncrasies, whether they're design related or they're issues associated with limitations on the platform, are critical and challenges that you will encounter. It usually does involve more testing. As soon as you take on a new platform and you want to be able to support those platforms, let's say you support Windows today, but you want to support Android and iOS tomorrow, you want to share a lot of code across those platforms, you need to test to make sure that it works, right? So obviously that increases your QA/QC process. So something to think about as far as a challenge moving forward when choosing a cross-platform solution. Right, so building native apps, multiple platforms. So which one's right for you? Great question. Obviously, in many cases, you're coming in with existing or pre-existing knowledge, or you have yourself or a development team with knowledge or development tools that you're familiar with and workflows for managing source code. And being able to leverage those in a way that best fits your current or existing development patterns is critical, right? So it's subjective. You have to understand what your development team has and what your users are asking for, right? So which platforms do you choose? What do we support? What is supported? And then what technology or what capabilities do you have? In general, be prepared to learn something new, right? So if you're familiar with one technology, and generally if you're a developer, you are at least with one, hopefully. Call yourself a developer, right? So you're familiar with the technology and maybe one or two or three platforms, and you want to enhance that skill set and work with other complementary technologies to expand your reach. You're probably going to have to learn how to work with that platform more immersively and the different idiosyncrasies that go along with it. Before I dive into the multiple players and we get into some more details, I just want to mention one thing here, and we're not going to focus on that in this one, but just want to highlight that we have a set of off-the-shelf ArcGIS apps, right, that work with our platform: Collector, Workforce, Navigator, Explorer. Right? These are designed to work on many different platforms, inevitably, that enable you to go into the field with solutions without having to build it yourself. Right? So something to think about there is that we do support apps across multiple platforms. If you're looking to build an app and you've got a set of data or a configuration that you want to work with, you want to be able to expose that as an app yourself, but you want to walk through the process of designing that, a WYSIWYG designer for building out a native application, provide something called App Studio. Right? So App Studio, it's built in our QML SDK, and it's designed to be able to build an application right now that looks and feels the same across many platforms, across almost every platform that we support at this stage. So we do have some options there. Just a couple things, a little bubble on the side there, just to remind you that we do have some solutions that don't require development. Right? So something to look at. But if you get to the point where you know that you're going to have to build out a cross-platform solution and use some developer techniques and an SDK, that's why we're here. Right? And that's what we want to present, is some of those solutions. So there's multiple players in this market, multiple technologies, competing technologies, whether we're working with Java or the Qt company or Microsoft or Apple, trying to build out different solutions that enable you to use their developer technology to work on another's platform, right, or others' platforms. And so there's a variety of players in the market. We're going to be focusing on just a couple of them. So if we look at some of our options here, and in this schematic, what we see is we have a common core, right? Our runtimes are built on a common shared native core, built using C++, on a variety and supporting a variety of different platforms, different operating systems, and different architectures, different rendering pipelines. But we build all that as one common core, and we share that or expose that as developer APIs so that developers can take advantage of this common shared logic. Now I highlighted here in white 3 different APIs or SDKs that we provide today that we will focus on in this session as far as cross-platform solutions: Java, Qt QML, and .NET and Xamarin. Right? The key thing to keep in mind is these are really just windows or ways of exposing this common functionality, this native high-performance functionality to multiple platforms using industry standard APIs. And that's the critical piece. So how are we going to cover this? We've got 3 different technologies we're going to cover. We're going to start with Java. Eric Bader is going to run through some of the capabilities with Java and different supported desktop platforms. Qt QML, Michael Timms will walk us through the process of supporting just about every operating system with Qt QML, leveraging C++. And then we'll wrap up with a .NET or Xamarin solution. Morton will walk us through the process of integrating or utilizing the .NET, the framework, the Microsoft development tools and capabilities to be able to target Windows, iOS, and Android. So I'm going to hand this off to Eric, and he'll take us through Java.
Great. Thanks, Rex. I think I'm on number 3, right? And just the fact that there are a gazillion devices up here it shows that cross-platform for runtime is kind of a natural. But anyway, so I work with the Java teams at Esri, and in the industry, out in the market, in the world, Java's everywhere. There's billions of devices that have JVMs on them, and millions of applications running Java. And so it's natural for the runtime to have a cross-platform Java API. Java's designed for cross-platform, so it's very natural. However, you write applications for multiple platforms with the runtime for Java. However, right now, we compile that core that Rex alluded to specific Windows and Linux machines. So you couldn't really take a pure runtime Java application and run it on a Raspberry Pi. You could if we took that C++ core and compiled it for that platform. But right now we don't ship that. But someone could technically do that if we go down that road. So today the runtime supports Windows and Linux. You can write on Windows, deploy on Windows and Linux. You can write on Linux, deploy to Linux machines, Ubuntu, Red Hat. And then the beta that just came out for Quartz, beta 2 for Java, shows Mac OS support as well, so you can build applications on Mac and deploy them to Mac as well. And as Rex did allude to for Java, we're aimed at Java SE applications. These are applications that run in desktop client applications. Of course, Java is very prolific in the back office and server space too, but the runtime is tailored for building rich Java SE applications. And the way that you write and use the API is very cross-platform as well. And since there's a JVM on every device out there, you program as if you can deploy to any of those that we support, right? And as Rex said, it sits on top of the ArcGIS runtime architecture, the core. So whatever that's compiled to, that's what will run. So the experience of a Java developer building for cross-platform with the runtime kind of goes like this. You start off here in your IDE of choice, whether it's IntelliJ or NetBeans or Eclipse, and you build your application in Java. You write Java code, and you export that to a deployable and a runnable jar file, for example. And then you deploy that jar along with the native libraries that come with the runtime that you get as the developer. And together, that jar, along with the runtime native DLLs for those specific Windows, Linux, or Mac OS, your application just runs. So your Java code loads up in the JVM for any of those systems, and the native libraries are there, whether they're DLL files for Windows or shared object files for Linux and dylibs for the Mac. So that's pretty much the straightforward way of development and cross-platform deployment with Java runtime. There's some considerations to keep in mind. For the most part, it works, but of course, you have to think of some frameworks that you're going to be running in the JVM of your choice, right? You have user experiences for Swing that give you a lot of tools that give you a common experience across, and you can change the look and feel of those applications to be either common across all platforms or specific to that platform, and make that work. There's other considerations to keep in mind that local server, if you're going to be using that for your heavy lifting of geoprocessing, for example, in your Java desktop applications, we have that running on Linux and Windows only at this time. And some other things to keep in mind as a Java cross-platform developer, if you've done this before, you know the different file path separators for different Mac, Linux. Windows will always use the // so it's always safe if you're going to do Windows and Linux or Windows and Mac. You can use the // for your paths. And then, of course, Java supports that system property to get the file separator. That's a really good practice to have so that it really doesn't matter. You can port your code pretty easily across different platforms. So let me show you an application, a very simple application that was built with Java runtime. If I actually have it here going. Right. I'm in my IDE right now of choice. I like them all, but I'm in Eclipse here. And I have a simple application that I'm going to run that does some routing and geocoding and reverse geocoding all at the same time. Once I can actually start here. I apologize. And what this will do is I drag the mouse across the screen. I'll click up here and geocode a location and also reverse geocode that location. And then as I drag around, I'll perform that route analysis for optimized routing. This is a point-to-point. So that I built on Windows, right? And if we look at the code here, we see that You create a route task. And then notice that the route task that I'm instantiating is using a network data set that's local, right? It's on my system, it's local to my running class files, right? And so then now that it's kind of relative, which is a good practice, I don't really need to specify the full path name. I can actually use a relative path to that network data set. Also the same is here with my the data for doing the geocoding and reverse geocoding as well. So this is all just, I have a base map that's online, but all my operations are working locally on here. So since this is /, it'll always work on Windows, Linux, Mac, or what have you. And as I move the mouse, I'll perform my solve route task based on the 2-point as I drag. And then as I drag, I'll also do the reverse geocode asynchronously, and then get the attributes of that result and get the graphics and then keep painting them on the screen. So pretty straightforward little simple application that does routing, but I want to show you what it looks like as a deployment. So I took the Java code and exported as a simple jar file, right? An executable jar. And then I took the JNI libs from my runtime installation on my development machine. And as you can see, there's Linux 32, 64-bit, Mac OS 64, Windows 32 and 64-bit. These are all the native libraries. And they're all just sitting there relative to my jar file, my executable jar file. And then there are resources too, right here, that I need for the performance of display and all of the other things. And then here's my data relative. So here's my geodatabase that has my network data set in there, and then my locators are right here as well. So I can, because I have this big old fat, JNI deployment, I can take these libs and just take this and put it anywhere, the same deployment, though it's big. Or I can strip it down and just run it on Mac, let's say. So this same application, is this one? So this same application, that same deployment file is here on my Mac, and I didn't really change anything. I just built it on Windows and deployed it to, which I'm not on the network, so therefore, we're not going to see the base map there. But I'm going to select that, just pretend you didn't see that, and as I connect, I'll start that up again. But it'll fire up and be the exact same Java application that I built on Windows. So this is kind of our cross-platform story right here, and it still runs exactly as it did on Windows. And then, of course, like I said, this same one will run on Linux 32 or 64-bit because I have those native libraries right here in my JNI libs. And so, therefore, that's all I have to really show. We can talk more at the developer island, but I'm going to pass it on to my colleague, Michael Timms, who is on 4.
Great. Thanks, Eric. So, hi, my name is Michael Timms. I'm a lead developer on the ArcGIS Runtime SDK for Qt, which also uses the QML API. I'll talk to you a little bit about the pros and cons and some things you ought to know about when using ArcGIS Runtime SDK for Qt. Just a little background. Qt is developed by the Qt company. They've been developing cross-platform framework for 20 years, so it's definitely their specialty, the cross-platform realm. They have this one framework that you can use that provides a C++ API and also provides QML, where you can code once and you can run anywhere on any device. They have many users, many downloads, a lot of developers, whether they're indie or corporate, and a pretty significantly large open source community that's constantly contributing back to the framework. So that makes it really nice and powerful to be able to have that open source community. And they, proven to speed time to market by 50% for cross-platform is what they claim. Now I'll go through just some platform support for the ArcGIS Runtime SDK for Qt. At our 10.2x release, we have a C++ API that works cross-platform on Windows and Linux, and also a QML API that runs cross-platform on Windows, Linux, macOS, Android, and iOS. And this is the API that you would get if you are using App Studio. For Quartz, which is our next major release of the Runtime SDKs, we'll be bringing in support across the board for the C++ API, so you'll even be able to develop mobile apps and develop on macOS. And also the Windows Universal Platform we'll be bringing to life, and we'll be adding that in for the QML API as well. So just kind of an idea of what you have for platform support. Quartz is scheduled for Q4 of this year, final. You could already try the beta release today for all of the Runtime SDKs. Yeah.
You can get to it from developers.arcgis.com.
Correct.
Yeah,
Okay.
great.
Cool.
We stole
Thanks.
your thunder, so
Thanks, Rex.
it's all good.
So Qt. What we deliver is one SDK with the two APIs, the C++ API, the QML API, and you have your choice to choose either. They don't really work with each other, but they're two separate APIs. You're going to use Qt Creator. This is what you're going to want to use when you're using Qt because it's a cross-platform IDE. So when you're going back and forth from different platform to platform, it's nice to have the Qt Creator IDE, but then you got to remember that this is a new IDE you have to learn how to use to be able to design and develop your app. But in addition, it's nice in the case that you can test and you can deploy straight from this IDE, and I'll show you kind of a little bit of that coming up. One thing to note about iOS, today in Qt, I believe even with their latest release, if you want to do deployment where you're creating an IPA to be able to distribute in your enterprise or to be able to put into the App Store, you do need to go into Xcode in order to give your application some of the thumbnails and the splash screen and the icons. You do need to do that, so that is one thing to be familiar with. We do have instructions on our developer page on how to do that, where you're basically designing in Creator and then go over to Xcode when it comes time to deploy. For the C++ API at 10.2.6, which is our current release, we have Qt widgets for the UI. Qt widgets is sort of the traditional way of writing your UI in the C++ API. And then for C++ API at Quartz, the way we're getting that cross-platform support with the C++ API is we're actually allowing you to write your UI in QML. So you'll have your map view or your scene view in QML, but you'll be able to bring the business logic down into C++ and actually write all your business logic in C++ and leave the UI to QML, because QML is a very strong UI-based language. C++, we use modern C++ language. Qt has even enhanced that with their latest release of the framework. Very quick performance with C++. We get this direct binding onto the runtime core, so it's usually really, really quick. And then the QML API. How many of you have used QML or App Studio? Not a whole lot of you. How many of you are JavaScript developers? You've used JavaScript. So a number of you. So the reason I point that out is because QML API is built on top of a JavaScript engine that is packaged within the Qt framework. They deliver a ECMA 5th edition JavaScript engine that runs behind the scenes. And what we get with the QML API is we get this nice, easy to read sort of JSON CSS-like syntax that you get where you're basically declaring out types and putting them within your QML code and anchoring them appropriately. Here we have a map where we're anchoring to fill a parent, and basically you lay out your UI in that way. So yeah, I talked about declarative UI elements. And then we have imperative JavaScript code as well. So you're able to handle events from the types, like for the button in this case. And when it has some sort of event that's occurred, they call them signals in Qt and QML. You're essentially writing in JavaScript code at that point. So you can declare a var and hook it up to an extent, and then tell the map to zoom to that particular extent. And that's all pretty much running with JavaScript and allowing you to use your JavaScript code. You can even call JavaScript functions from that signal handler. We get dynamic property bindings. So here we have an enabled property that's hooking up to the map status, determining whether the map status is ready or not. Once it actually, that Java expression evaluates, then the enabled property automatically gets set to true. So it saves you a lot of time, conditionalizing your code. You can use this property binding dynamically. And then we bring in the ArcGIS runtime on top of the QML language. So JavaScript and QML, I'll go over a little bit about this. I saw quite a few hands for JavaScript. If you understand JSON and JavaScript, QML is going to come naturally to you. We hear that over and over at the island when we're talking to a lot of you. Implements ECMA 262 5th edition. It means that you'll get access to Java, date, and object and array. You'll get access to a lot of those things. You can call JavaScript functions from QML. You can even import JS files to be able to call functions that you've imported from your JS files. And then, like I showed before, you can bind properties to JavaScript expressions. Here we go, object, array, math, and date. So you can get access to these standard types. Any major differences with, say, for instance, the browser? Well, you're not in a browser, you don't get the DOM or the window object, and you don't get access to some of those frameworks like Dojo and jQuery. You're actually working within the Qt framework, so the JavaScript engine that's running within Qt, that 5th edition, you can typically get access to those, but you really can't bring in any other frameworks into it like you could in the browser. So now I'm going to go through a quick demo. Because this is a native API, not to be confused with a web API or one of these web to native hybrid APIs. The QML API is purely native. We can get access to the different capabilities of the device, like, for instance, the sensors. So this is a quick little demo where I just have a base map up on the screen, and we can actually switch between a light theme. We can switch our UI accordingly depending on if it's light outside or dark outside. Maybe you have field workers that work in the daytime, field workers that work at night, and you don't really want to have them have some sort of toggle switch or anything like that. So this is just a little example on how we can hook into the ambient light sensor of the device, the Samsung Galaxy S5. So if I just took this device and stuck it under the table where it's dark, we can just dynamically update the UI, bring it out, go back in, and also the renderer changes. So this is one way to just show you how we can get access to the sensors and also use some JavaScript expressions to update our UI. And I think I have some code. So I wanted to step you through some more QML code. This is code for 10.2.6. Quartz is pretty similar, but this is just, I'm going to show you some code at 10.2.6. So we have a map, and the way that you add layers to your map is you essentially just you nest in the layers. So here I'm nesting in a dark gray base map and a light gray base map and a graphics layer. So that's really how easy it is just to add operational layers into your map. It kind of looks a lot like the new way that you instantiate types in the JavaScript 4.0 API, how you can kind of nest everything in and you have properties that you can declare and hook up to. It's very similar to that API I found when I was checking out the ArcGIS JavaScript API earlier this week. And then to hook into these sensors, there's many of them. I'll show you a couple more of them. Ambient light sensor. You can typically just declare the sensor, and it'll have a signal handler that you can hook up to when the reading changes. So when the reading light level changes, whether it's dark or not, you can hook into whether you want to change that property to true or false. And then when we were binding that property above to the layer's visible property, that's how we can hide the layer, and then the other one becomes visible. So it's a nice way of using those expressions to hook into your code. So now I'll continue on with the slides. Just a few of the native sensors. There's many of them, and they're available in C++ code or QML code, ambient light sensor, temperature sensor, pressure sensor. There's many of them. You could check out the Qt website to get an idea of which ones there are and which ones there aren't, because maybe you may want to use one that Qt doesn't support. So you definitely want to take a trip out to the Qt website to take a look at those sensors. Other things about Qt as cross-platform, we deliver an extras library with framework. And what that is, it's an additional plugin library that we deliver. App Studio has a similar thing that they call the app framework, where they have sort of these extra APIs that are not available in QML. So we're kind of the QML framework. So we're sort of making up for their lack of APIs. And this exists. There's quite a few APIs that you need to watch out for that aren't bubbled up to QML. They might be in Qt C++, but not quite bubbled up to QML. So we try to find those more common use APIs and expose them up through our extras, like the ability to get a quick scale factor. Actually, scale factor is kind of a bad example because that one you can get from QML. But that is something that you want to use when you're laying out your UI. Qt at their 5.6 release did not automatically scale the UI depending on the resolution of the device. Prior to 5.6. But at 5.6, they do allow you to configure your app out of the box so it does adjust the size of the different components like buttons and text depending on the DPI of the device. So that's actually really neat that they brought that in at 5.6, but something to be aware of because our existing software allows you to run with Qt 5.4.1 and above. The extras brings these high demand APIs. File IO is one of those. And then I mentioned App Studio's app framework. And then something to be aware of when you're dynamically linking and you're using shared libraries with your app, which you typically do on most platforms other than iOS, you've got to bring along those extra Qt binaries, and typically the Qt deployment process does that automatically for you. But it can increase your app size because some of those shared libraries in the Qt framework can get pretty big. So that's something to be aware of as well. Sort of continuing on the compiler SDK dependencies, if you're using the SDK directly, you will need the compiler, Visual Studio, Xcode, GCC compilers. You'll have to have those installed on the machine so that the Qt Creator IDE knows how to go in and actually work with the compiler. For Android, you need the NDK and the SDK, and we have the certain versions that you need on our website. But the good news is once you get this all set up, you're still using the same code across all the platforms for QML, but there is quite a bit of setup time involved. The good news is we have that all well documented on our website on how to get all set up with those different compilers. And then incomplete APIs from Qt. I kind of already touched on this a little bit. Qt does just wrap into their own implementation the APIs that are delivered from the iOS, iPhone SDK, Android SDKs. But there could be a few things that are maybe Android or iOS specific that they don't quite get at. One of the big ones I constantly hear about is client-side push notifications. Qt does not have that in their out-of-the-box framework. There are third-party providers that allow you to get source to be able to bring in push notifications. But that's one of the big ones that we're trying to push on the Qt company about, is getting that push notification support. Look and feel of the native platform, we'll look into this a little bit. It does wrap up the native look and feel of the platform. There are some things, like if you brought up a message box on iOS, it kind of looks like a Windows message box right now. Those are some things to watch out for when you're developing your apps. You could maybe need to, create your own type of UI if you wanted it to look exactly like the native platform. But Qt does have a nice advantage because it does allow you to have one manual per app if you wanted your API to look exactly the same. I know that's how a lot of the App Studio apps look like, where they have the same app and they sort of look the same across the board. Qt Android Services was something that was not available at Qt 5.6 and before, but at Qt 5.7 they've brought it in. So say for instance your application went in the background and it got suspended and you wanted to still collect location data. Well, at Qt 5.6 they didn't allow you to really spin up a service to do that. They're allowing you to do that at Qt 5.7. At 5.6 you'd have to write sort of the JNI C++ code yourself to do it. But at 5.7 they'll have an API for that. Here's a link with more information about that at 5.7. But something to be aware of for sure. Here's just a couple screenshots of Qt Quick Controls 1, because at before 5.7 there was just the Qt Quick Controls 1, and it's just a couple little screenshots of how you get the UI. This would be using a similar code whether you're running on Mac OS or Android, just in an example. They look a lot like the native platform, so that's actually really neat to get it to look a lot like the native platform. But you still may have to make some tweaks here and there for anything that may be missing, any sort of quick control that's not available from, say, the Android SDK. So some of those to be aware of. At Qt 5.7, Qt Quick Controls 2 actually comes into the picture, and they have all of these out-of-the-box controls. I didn't list them out here. This is just a couple of them drawn up on the screen. But what they're doing is they're allowing you to choose whether you want Google's Material Style or Windows Universal Style. So it'll look like, you can make it look like Google's Material Style whether you're running on an Android device or an iOS device. And this is really useful for those cases if you wanted it to just look the same across all of the different devices. Now I'll go over real quick just to show you one other thing. Yeah. Maybe not. Is that 3?
3. Sometimes you gotta kind of squeeze it a little bit.
Not having very good luck here.
As we tested this one. Oh, blipped.
Oh, there it goes. Okay. This is just a quick little demographics sample application where I can touch in a location and we'll calculate some statistical analysis here and get some data. And what I really wanted to show you is on the right side of this application where we have these out-of-the-box charting controls that are available in the Qt framework. So you could take the data and the query results that are given to you from the Runtime API and plug them into these out-of-the-box Qt controls. And they look and they feel the same. You can kind of drag them out and stuff like that. But they look and they feel the same across all of the different APIs. And I could use this same code and I can run this on an Android tablet and it would look exactly the same. So, now I think the last thing, so back in 4. So I think the last thing I wanted to do was go over everybody's favorite topic, Qt SDK licensing. So Qt does what you would do as application developers is they call it the Qt for Application Development License. And that's what you would typically want to look at when you're looking into, well, do you need to get licensed? Can you use open source? Do you need to go commercial? Most of the time, you are going to need to purchase a commercial license. If you're making money off of your software, Qt wants you to license. They do have a dual license under commercial and open sources, but open sources only really get you so far. So I would highly suggest visiting Qt.io/licensing and taking a look at the different license models. And even at, it's a little bit of a trick because at Qt 5.6, they were LGPL v2.1, and then they changed that at Qt 5.7 to be sort of a combination of some components are GPL, some are LGPL v3. So that's definitely, before you get started, go check out the licensing, see how it works, get in contact with the Qt company if you need to try to determine where you fit into the picture with the license model. And that's it for me. Now we'll go over to Morten.
Three. There we go. So, .NET. How many here are familiar or writing any code in .NET? Quite a few. How many here has a Windows phone? That's quite a lot. I didn't even expect that. It's actually a good problem because there's a lot of .NET developers that knows how to build apps for their Windows phones, which no one will use because there's hardly anyone left, unfortunately. It's a great phone. I love mine, but it is what it is, and we want to get in on the whole thing on iOS and Android, and we can't really do that with .NET, or can we? So there was this great project back in the day called Mono, which was an open source implementation of .NET. And it jumped through a few companies and ended up being cut, and then the guys that did that, they went out and made their own company called Xamarin. And the clever thing they did was they wrote compilers that could take C# code and generate Android and iPhone apps. Really, really clever. The guys are called Xamarin. And their company really exploded and did really well. I think at some point they had said that 25% of the apps in the iPhone store was built with Xamarin. I don't know if that's actually true, but they definitely have, I think they have 6 million downloads of registered developers. Microsoft ended up buying them this year. With respect to licensing of Qt, with Xamarin was also quite expensive until Microsoft bought them. They just made a whole thing free and open source, which is really, really cool. So the way you want to think about Xamarin is that Xamarin is a C# language around the Android SDK and a C# language around the iOS SDK. That's all it is. It's just a way to call those existing APIs. So you get every little bit of API that are available on that platform. You can just use C# instead of using Objective-C or Swift or Java. So for net developer, that's great because it's a language I'm familiar with. And in addition to that, they added a bunch of all the basic libraries that we all know, like system.math for doing calculations, or file operations and streams, and all those standard libraries. They're actually the same. And this is really cool because that means that a lot of my code can actually be shared. And if it needs something platform specific, then I can do that. Just kind of, I want to give you a little overview of how we actually built this because it might give you a good understanding of what we do afterwards. And we really have, in the .NET and Xamarin SDKs, we really have 4 platforms. We have the Windows platform, the good old classic Windows. And we have this new universal platform, which is more of a cleaned up sandbox version. It's in a sense of a subset that sits on top of the old Win32 APIs. And then, of course, there's iOS and Android. And you've kind of seen this box before that was shown, this runtime that goes across all the platforms we have. We have the same one. It goes across all of them. In fact, the iOS and Android bits that we compile, it's the exact same bits that our iOS and Android team are using and the Qt team are using. There's no difference. We only build those once. But what our .NET and Xamarin team then we do, we create this interop into .NET, and we then expose all of this as a nice .NET language. This is where it breaks off from how Qt and Android and iOS are doing it from the Runtime SDK. Internally, there's a different framework that runs in full desktop. This is the full .NET framework. In the universal platform, this is what's called .NET Core. Essentially the same thing, if you want to think about it that way. It does more or less the same things. There might be some APIs that are not available because you can't break out of the sandbox. And mono/Xamarin is what powers the iOS and Android bits. But again, it's pretty much the same. And then on the very, very top, we have a bit that just makes things work on WPF, Universal, iOS, and Android. So way of thinking of it, there's some internal stuff you don't have to worry about. This is just you know what's going on in the coverage, and then there's a public SDK. This is what you code against. All right? And so everything really happens in C++. That's why everything works the same way on all our different SDKs. But what you want to, the blue box is actually where everything is the same for all these 4 platforms. The code against you write against the blue boxes are the same, and the purple one is actually what you're, think of the map control. That's really all that is. It's the only thing that's up there. They're almost identical anyway, but because they inherit the views from the base platforms, there's some concept that's going to get pulled over. They all have different base classes and so on. But as much as we can make them the same in our bits, we are making that the same. So again, that's just the map. You're seeing pretty much everything else, maps, layers, data, location, all that we actually abstract away in one generic API. So that means that a lot of the code you write for one platform can be reused. But there is that native piece, which is actually different in all of them. And it can be a little cumbersome. So Xamarin actually provides something called Xamarin Forms for 3 of the 4 platforms. And this is a UI framework that abstracts it away for all of them. And this is a little closer to actually what Qt does, where they have their own common UI layer. Whereas the purple row, those are very platform specific. So it kind of gives you the benefits of both. There's every single API that a platform has, you can get at, where Qt can be a little more limited on it. But it also means it abstracts out and you get different, you get code that has to be a little different on each platform. So there's pros and cons to that. Xamarin Forms tried to solve that by creating a generic UI framework, because it's generally the most part where you're writing different code. There'll still be some other things like file system might be different, how you get the access to GPS and so on. Those all look different each platform. But let's look at something. I want to show you a little app I built. I'm just going to quickly run it here. Our campus is getting kind of big, and they renamed all our hallways, so I can never find the office I need to go, or the meeting room I have to go to. I always get lost. So I figured, why not write an app that actually fixes that problem? So we have a map of the campus, and maybe I arrive as a guest by the receptionist, which is right here. And maybe I have to visit the usability lab. And it should calculate a route. It actually gives you 2 routes. I think this is very clever, because there's actually been a day this year where it rained in California. And so to avoid getting too wet, it has a dashed line that gives you a little detour, but only this little bit here is outside, but it tries to favor going inside. So it gives you a little detour, but then you can stay out of the rain and not get wet. But it just uses our local geocoder and network task to perform these calculations. Super cool, and a great app to have. I built this on Windows. One of my coworkers are, but I have an iPhone, or I have an Android, or most of our guests that want to use an app like this, they don't have a Windows phone either. By the way, this does actually run on my Windows phone. This is right, you can see it here. It's the exact same app. Actually, it's literally the same app, and that's one of the promises of the universal platform, is that you build the app once and run on all the Windows 10 devices. And I'll get a little more back into that later. But again, I want to bring this to Android and iOS. So, of course, Xamarin is my obvious choice because I'm a .NET developer, and I've already written all the code. So let me close that. So I want to show you my little project here. Close this. You'll see I have a little group here that's called Platforms. And there's a UWP, which is Universal Windows App. That's the one I just ran. But there's also an iOS and Android app. And at the top here, I have something called Business Logic, which is a shared project. This is all the code that I share, and this is actually by far most of it. It does the route calculation, it sets up the map, it downloads the data. The first time you run it, it goes online and downloads all the data, and then it works offline after that point. So that's the provision data helper, that's the route helper, and so on. So it performs all that operation. This is all the business logic. This is me coding against that big blue box in the diagram. And here you actually see the XAML. So it's Visual Studio has been kind enough to underline the map control. I'm not really sure what's going on, but that is the map control in XAML. But this is XAML for Windows Universal. In Android, it's a little bit different. It has this thing called AXML. You actually see an Android view here. And if I go in and look, if you've ever been doing any Android development, this will look familiar to you. This is actually just there. You can kind of think of it as almost a XAML for those of you who are not familiar with it, but no XAML. There's also some code for that sets this up. There's a little more code because I don't have binding here. There's much less code in the XAML for doing similar things. So this is where things get different because the UI is just a different thing on each platform. So this is where I actually do extra work. Similar for iOS. Here is my UI view control, which is an iOS thing. So it's been on iOS. They actually would probably notice some of these classes. They might have been slightly renamed just to make it look like .NET, but these are actual literally iOS controls that you're coding against and setting up the view. So actually let me set this as a startup project. And just to show this is actually real, let me go, let's say, here I set up my map. So I'm just going to set a breakpoint. Launch my Android app over here. So I just run the simulator. One, two, three, 4, 5, 6, 7, 8, 9, 10, go. Right before we started, my virus scanner was using 65% of my CPU. I don't know if that's going off again. I promise you it's real. I could just cheat and just launch the app. Oh, no, it disappeared. Oh, I can't. It's already deploying it again. Oh, that's not good. There it is again. Deploying it. Setting up. Oh, it's hit my breakpoint. In Visual Studio, I'm sitting and debugging an Android app. I think that's pretty cool because I like Visual Studio. That's the way I work every day. I can sit and step through my code, and I can just hit F5. And with a little luck, the same app is running here. Whoops. Yeah. And I can do the same thing. I can start geocoding. Exact same code. It's pretty cool. Let's do iOS just for good order. Here's the iOS app. It looks a little bit different because I've adapted the UI to make it look a little more like iOS, so I can actually do stuff like that, change it. So here's let's go to that conference room maybe. There you go. Cool. So now I can actually do that. But as I mentioned, I write a lot of code again and again and again for each UI, and Xamarin Forms can actually fix that for me. So I actually prepared a different set of projects right here. And this is using forms, and the first three are the only thing I did to these three first projects was I added the runtime as a reference. Else it was just the default projects that Visual Studio created. Oh, sorry, can you switch back? My bad.
Sorry, no, my bad.
There we go. So I have a little form for 4 projects. That's the Android, the iOS, the universal one, and the shared project. The first 3, I literally didn't write any code. It's just the default code that launches the app that sets up the app name and the assets and icons. It's just the default ones. I haven't touched those. But all the actual magic happens inside the Forms one. I have a XAML page. I could get XAML with Xamarin Forms. It's a little slightly different flavor of XAML. It does look very similar to Esri column map view, but I don't know why they did this, but a text box is called label. It's very frustrating. I keep forgetting. So they tweaked it a little bit, but essentially it's the same concept. You get full binding and all those things, so it's very, very familiar. Literally, I took the universal app, I copied the XAML in, tweaked it a little bit for the Xamarin flavor, and it ran. It was under an hour before it was running because I just grabbed that shared project with all the business logic and just pulled in, and that was it. And it runs on all 3 platforms. I think that's pretty cool. You do get, now you have a least common denominator kind of UI, and it can get a little more tricky if you want to start adapt. They do have some ways to set, if I'm on Android, make the background color green instead of white or whatever. So there are some tweaks you can really quickly do. So some people don't want to do forms. They like to really get down in nitty-gritty details of these patterns and really adapt to it, but that can also be very time-consuming. It might not be worth it. And then forms can actually be a really good alternative to that. Cool. I do want to talk about a little different thing. I did mention Universal Platform, and in itself, you could consider the universal platform a cross-platform, or as Microsoft call it, a cross-device family platform. So what they kind of been working towards this through Windows 8 and 8.1, but it didn't really become real until Windows 10, where the core that runs on all their devices is Windows 10, down to the binary level where the app that I just showed you running on my tablet or my PC also runs on my phone. It's the same app because it's the same core. There's the same set of APIs that I can always work with. The difference is what they call device families. So of course there's a PC or a tablet. That's one device family. There's the phone. There's the mobile device family. They have the Raspberry Pi or a Dragon Board. I have a Dragon Board up here, which is an IoT device family. So you can run on Raspberry Pi 2 or 3. There's the HoloLens. There's the Xbox. They all run Windows 10. And this app I just showed you runs on all of these. In fact, here I actually have a little bit of a LCD kind of mixed together. This is the app you saw. If those are up front, it might be hard to see, but there's actually only a to line on this one. There's not a from line. And the reason I did that is I was thinking this is the kind of app you would mount on a wall at the reception center, and you already know where you're at. It's like you are here. So you hard code that in, and then you only have where do I need to go. And it is still the same app. It is actually still not a different app. Because if you were to look a little closely at my app over here, you might have noticed I have a little device from this IoT, and if I expand that, I have a main page XAML here, and I actually made it really simple. I hard-coded in, let's see, that's the search from box. I hard-coded where I'm at the reception, but I just made the first row 0, so just collapsed it. So basically just hard-coded the first line in. So what it does is, oh, this app is running on an IoT device. Let me load this XAML instead, but still use the same code behind. That's also one for holographic. You guys know what holographic is? It's this little fun device. So it'll actually run on this too. And the only reason I did this for holographic was because I didn't want to bother actually entering the location. But let's try my most risky demo of the day. Let's see if it'll run on here. As you know from earlier, it's online. That's a good sign. All right. Oh. There it is. You guys see yourself. You're on camera. Let me just make sure I'm running in fastest mode. There we go. So the quality is a little worse because the Wi-Fi is just not for it. So hopefully in a sec it'll recognize where I am and remember. It actually scans the room and recognizes rooms and remember where I put things. Let's see if it can remember where I am. Sometimes it takes a sec. Or if I'm getting lazy, I can just say, I want to find my app. Is it behind over there? Is it keeping up? I can actually take an app. I can place it. Let's put it, let me see my wire. I'll put it on the wall over here. How's that? There's the app. I can even go and use my finger. I can pan it around. I can click the drag tool. Oh, it's a little bit behind over here, I believe. So bear with me. Zoom tool. Zoom like that. The quality is a lot better in here than what you see up here. I'm sorry for the streaming quality. But this is not really the kind of app you want to run. I think they're really, oh, you see the other app behind there? That's the app I placed earlier on the wall. And there's it again. And I think I put some, so you'd actually, oh, there you have a bunch of things I had placed around the room earlier. It just took a sec for it to realize. It's kind of cool. You come home and then suddenly the apps you put around the walls, like in the kitchen, you have the recipe website up on the kitchen, up in the fridge, and it's really, really impressive. But the really cool thing is running 3D. So, whoa, this is up a little high. Let me actually close that again and start it. I'm just going to relaunch the app. So if I use something like Unity, which is the 3D game engine, it actually has full support for doing 3D rendering inside HoloLens. But what Unity really does is when you're done building it in their app, it actually generates a universal app. And I can add a reference to our SDK because it's a universal SDK. And then I can actually call code in our runtime.
I'm going to have to reset the video.
Did the video drop?
Yeah. Just have to restart.
Let's see. There we go.
Yep, there we go.
This is a bit of Palm Springs. I grab some terrain from ArcGIS Online, and I generate this little model in Unity. But I can actually tap on here and say, boom. And I get a geocode, REST geocode. I'll do a few of them. And this is actually the runtime running inside the thing. So yeah, I don't use the runtime's rendering engine, I use Unity's right now, but I actually can call code. Because it's a universal platform and everything is the same, that code will run. And if there's a new device coming out tomorrow that also runs Windows 10, our product probably runs on it. Now, we haven't actually certified for running on IoT Core or HoloLens or an Xbox and so on. If it's something you guys really want, we'll certify it. But actually, it is real. It's not something that we just made up and you can't do it. You can go and download the beta today and do exactly what I did. It's just if there's bugs in there and that doesn't work, we might fix them, we might not. If they're easy to fix them, we will. We actually fix some bugs for IoT. But I think it's pretty cool. So it's kind of a different type of cross-platform, which is more cross-device, where our API suddenly just lights up on all these other devices, even though we didn't really intend to begin with. I think you tried it on the Xbox, right?
Yep. So I deployed one to the Xbox, worked like a champ. Just got to write in, you got to build the navigation actually into the application to work. But
I actually thought about adding out of the box Xbox controller support. So if you were to do this, it would just work.
Yep.
But
all right. So pretty exciting times. Actually, it's fun. It's fun to see. So maybe next, there we go. So maybe next year, like half you guys will be wearing headsets, actually seeing things that others don't, or maybe collaborating with each other, seeing the same surfaces. Good times.
This might not be the best use of the HoloLens, my specific demo. It's more the point that I can actually call these APIs. I'd like to see what you guys can come up with. That'd be really, really cool. Start pulling in feature data and rendering it and all sorts of things via our APIs.
Yeah. So we're really looking, as part of a future effort, we're really looking at ways of integrating some of these newer technologies, newer platforms, actually so that you can leverage some of the ArcGIS platform capabilities, let alone building native applications, but some of the data sources and other resources that are available as part of the platform. So you can integrate those in these sort of exciting new ways of looking at your data. So good times, actually. So good times ahead. So what I'd like to do at this stage, and thanks guys for going through those, is just do a brief, just a real quick covering overview of the release schedule. So a lot of the technologies we saw up here today, some of them are available now, actually in a commercial release, in 10.2, some number, 10.2.6, 10.2.7, 10.2.8, for Qt, Java, and .NET. But if you're looking to start on something today, and you're looking to move forward on a cross-platform solution, I want you to take a look at Quartz. Now, Quartz is really a name for the first release of the next generation of the runtime. So this first release went out across the board on every runtime SDK in beta this month. So last week we released a beta of every runtime SDK, including the ones that we covered up here on stage as part of our cross-platform solutions. The first commercial release is scheduled for later this year. We're currently scheduled for November later this year. So we're targeting a commercial release where you can actually build out that solution and go into production. Granted, there are some, if you need to build something today, it needs to go out between now and then obviously we do have some solutions today built on our 10.2x architecture. But this is where we'd like for you to start if you can. Now, in some cases, we actually don't have a 10.2x solution. So for example, .NET support on top of Xamarin, building for iOS and Android is only in Quartz. Right? So if that's what you're looking to build out, then Quartz is your only solution. So if you're looking for Xamarin, actually. Yep, exactly. So, so this is our release schedule actually for the runtimes across the board with respect to our Quartz release. And then at this stage, let's open it up for questions. I'm sure there's a variety of questions. Obviously, we covered cross-platform, which dealt with development platform as well as device platform. So a variety of different cross-platform contexts. But are there any questions for myself or the panel up here going into this? Okay, if there's any, I'm going to put this up just in case.
So this is not related more to the ArcGIS, but with Qt itself. So with Qt, are you able to take advantage of all of the native libraries that are in? I understand when you were talking about JavaScript, you were saying that you couldn't take advantage of Dojo and so on, but the native libraries of the operating system, if you will. Like for instance, if you're running on iOS, are you able to access Bluetooth? Things like that.
Yeah, so the question was, so when you're using QML or Qt, can you get access to more of the device or the platform capabilities, such as Bluetooth? Is that accurate. Yeah. So the answer to that is yes. There's many of them that you'll be able to get access to when it comes to the device and its sensors and Bluetooth capabilities. That you're able to get access to those with Qt because it still is a native API. But like I had mentioned, there are still a couple of them where they're sort of fundamental, like push notifications, which you won't be able to get access to. And then like the Android services was coming in at 5.7. You'll be able to do that, but with 5.6, you have to do it yourself. It's kind of a mix. But the majority of those sensor types, if you're asking about Bluetooth, camera, any of those types of things, you can get access to those in QML. Yeah. If there's any specific ones you have questions about, go ahead and come find me, come see me at the island, and we can go through that. Anybody, if you have any questions about that.
Great. I put up just a URL in case you guys are looking for additional information on any of the products that we presented today. Access to the betas, great place to start. You want to read up on some of the information about choosing the right platform, whether or not you choose native or web, and when you choose native, what are the capabilities and options that you have available. It's a great place to go on our developer site to get started. It's all available there. Any other questions?
Yeah.
Yes.
Okay, so is there a good breakdown of licensing for runtime and what feature set requires a license and what are the options for getting that license? Because I talked to some of our others that always, I've been hearing all these great things about runtime, we talk about moving to it, but then I know someone doesn't that require a license?
It's a great question. We have a current published. Yep. It's a great question. We have a current published license structure actually for our current released products, actually our commercially released products that you can use in production today. We don't have something published yet, and we don't have information on that yet on what we're going to be releasing with our Quartz product, our Quartz line at this stage. That'll be coming shortly. Obviously, it'll need to be there for our production release later this year. So the licensing information that you find today is for our current 10.2x products.
And that's up there on that. You can find it on that site. Under license your app for any of the.
So I think the biggest confusion has been over the named user, ArcGIS online authorization versus baking it in.
Right. So there's two different mechanisms. Just to kind of summarize, there's two different mechanisms. There's a license string. There's a named user approach. The license string is a per app per deployment, per app per device string that you can bake into an application. It doesn't expire, but it requires maintenance. The named user approach, license travels with the user, and so you can build your application so that when you log in, it licenses the app for use at a standard level. So there's really just two license levels at this stage. There's basic and standard. Basic is free. All it requires is a client ID, right? Standard, when you reach standard, requires a client ID still, but then you'll have to go with one of these two options, named user or license string, right? Depending upon the needs and the requirements of your app. So, and there's different pricing associated with those as well. So hopefully that helps. That's the quick summary on that one. If you want more details on that, we can walk through it as well. So let me know. Yes.
With Xamarin, I had a situation where I tried it on the Mac OS, not with .NET. I don't know why. I should have tried it first probably on a Windows machine with Visual Studio C#, but I tried it on Mac OS. It wasn't a very good experience during installation.
You mean Xamarin Studio?
Yeah.
Using Xamarin Studio.
Xamarin Studio on Mac.
Yeah, I think it's. It was funny. A little fun story. I was working to the cafe, talking to my boss, and telling him how it was going with Xamarin, and he said we just struggle with all these issues with Xamarin, and it's crashing, or sometimes one day it doesn't work, the next day it's just fine again, and we don't know why. He said, you know what? It would be nice if Microsoft would buy Xamarin because something they do well is their tools. I literally walked back into my office and saw the announcement that they just bought. I said, "It worked. You should ask for that sooner." So I agree. There is definitely some issues with some of Xamarin. Some of you sit and struggle with. Like 2 hours ago, my Android app wouldn't run. And it wouldn't compile or deploy. I didn't know why. And then I just removed the reference, re-added them, and it worked again. No idea why. So there can be a little bit of frustration with that. It's definitely gotten a lot better. You can use Xamarin Studio on Mac. You can also, I didn't show that, I don't have a Mac right here, but you can run Parallels on a Mac. and then based on Windows on there, and then I think I actually forgot to mention, if you want to build your iOS app, and the reason why I didn't show building it is actually you need to have a Mac to build the app. You cannot build the app on Windows. You can sit and code it here, and you can build your libraries, but the actual app deployment requires a Mac. That's Apple's requirement, basically. But so the way you can do it from Visual Studio is that you can connect to a build host. You can use your Mac as a build host. And with Parallels, it can be the same machine because it just connects back to itself. So that's one way to do it, and you get the tools of Visual Studio there, which is really neat. That's another way. Actually, they just deprecated Xamarin Studio on Windows, and it's only focused on Visual Studio for the Windows side. They're still continuing Xamarin Studio on iOS.
OS 10, yeah.
OS 10, sorry.
Right.
OS 10, not iOS.
Right.
My bad.
So Xamarin Studio is still supported. So there's a simulation. This acquisition just went through about 4 months ago, right? So they're still in the process of iterating through a variety of different options where they can accommodate and consolidate some of the technology. They just deprecated Xamarin Android Player, actually, which I enjoyed, but now it's deprecated as of earlier this month, right? So there's different pieces of the technology stack that they're pulling out that don't really make sense to compete with something that already existed or that Microsoft already has, right? So Xamarin Studio appears to be the .NET or C# development IDE of choice, actually, with respect to targeting Apple or Android devices. Leveraging Xamarin. Actually, if you have a Mac OS and you want to leverage that platform to be able to build those applications. So Xamarin Studio for OS 10 is still available. Obviously, if it's on Windows, Visual Studio is critical, right? It is the developer IDE that you use, regardless of whether you're targeting Windows, iOS, or Android, right? So there's a consolidation effort that's going on at this stage.
So basically, just to confirm, you notice that it works on Windows or on Visual Studio much better than it does on Xamarin Studio.
No, I think my point is it's gotten a lot better, and it's improving. It definitely is. It used to be a lot worse when we started the Xamarin project. It was really a pain, and it is.
So Visual Studio is more
better.
mature. It's a more mature IDE, right? Xamarin Studio has only existed for 3 years, actually, right? So it's I think at best, actually. So if you're looking at the breadth and depth of the experience that Microsoft brings to the table in providing a world-class IDE such as Visual Studio, that really doesn't compare to the efforts, the admirable efforts by Xamarin to be able to put together a developer experience on Mac, right, on an OS 10 device. So with Microsoft owning the product and it being an IDE that's available on OS 10, they haven't deprecated it. Matter of fact, they're encouraging developers who want to use a Mac and OS 10 to be able to build applications that utilize or leverage Xamarin. They're encouraging people to use Xamarin Studio for OS 10. Morten mentioned Xamarin Studio for Windows is not encouraged, is not being used, right? It was there, but we don't need it. We have Visual Studio, right? Exactly.
It's so they can focus on doing a proper job just on Mac and focus on doing a proper job just on. So it's them like cutting down what do we really need and make those things much better, because there is definitely some improvements that could be made, and they already made a lot. So what I'm saying is try it again, see what you think now, or go the Visual Studio route. Not to say that that's problem free either. There are some issues now and then where you said, well, why is it not working right now? It was just working, and then a little later it's working again. You're not really sure. I mean, you get a lot for the bang for the buck.
You do.
People seem to be able to live with those issues because you get all those platforms.
It's either that or nothing. Yeah. So.
Or Qt.
So yeah, exactly. Or Qt. There we go. So a few of the sessions. Obviously, we're getting kind of late in the conference here. But a few of the sessions later today in the Demo Theater 3, actually both the developer Demo Theater. So it's 3D mapping for ArcGIS Runtime. We would be talking about 3D across all platforms, which will cover some of the cross-platform solutions that we mentioned here. And then actually Morten has an integrating ArcGIS Runtime with devices and sensors, which is interesting. Actually, different platforms, I mean not developer platforms, but operating systems, right? And integrating with some of those capabilities on those platforms, which is interesting. So another dive into Runtime and its capabilities. Tomorrow there's a road ahead session, actually tomorrow afternoon for ArcGIS Runtime SDKs. This is where we're going to find out what we're planning to do in the future. Right, so that's tomorrow afternoon right before the party. So something to take a look at. And if you get the chance, feel free to cruise out to our native applications that were built with the Runtime that are available now to review our schedule and actually provide us with some feedback and take our survey on this session if you get the chance. So great. Thank you very much, guys. Thanks for joining us. Have a great rest of the conference.